The morning of November 4th, 1941, a cramped office in the Navy's Bureau of Ships, Washington, District of Columbia. John Charles Niedermair, Technical Director of Preliminary Ship Design, stared at a British dispatch that had just been placed on his desk by a naval colleague. The message was urgent, almost desperate. The Royal Navy needed a solution to an impossible problem. A seagoing vessel capable of carrying at least 500 tons of the newest tanks directly onto hostile beaches. They had tried everything. Modified tankers worked, but proved too slow and vulnerable. Smaller landing craft couldn't cross oceans. Nothing existed that could bridge the gap between ship and shore for heavy armor. The 48-year-old naval architect had spent his entire career solving problems that others considered impossible. Born in Union Hill, New Jersey, Niedermair had grown up exploring the maritime fringes of New York Harbor, watching massive ships navigate channels that seemed impossibly narrow. His scholarship to Webb Institute of Naval Architecture had launched a career devoted to understanding how ships behaved in conditions that challenged every assumption about seaworthiness and stability. He had helped raise the submarine S-51 from the Atlantic floor, using calculations so precise that senior officers claimed he had raised her with a lead pencil. Niedermair reached for an envelope. In the next 2 hours, working with nothing more than a pencil and his 30 years of naval architecture experience, he would sketch the rough outline of a vessel that would transport more tonnage, support more operations, and prove more decisive than any warship ever conceived. This wasn't glamorous work. No medals were awarded for designing cargo vessels. The Navy's attention focused on battleships and aircraft carriers, vessels that embodied American naval power through firepower and speed. But what Niedermair didn't understand as he drew those first lines was that he was creating the weapon that would move over 2 million tons of equipment across hostile waters and win the war. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The sketch appeared awkward, ungainly. A flat-bottomed vessel 328 feet long with a 50-foot beam, featuring a massive bow door that opened like a drawbridge, twin propellers positioned for shallow water operation, and a ballast system borrowed directly from submarine design. The concept called for deliberately beaching vessels weighing over 4,000 tons on enemy shores, then pumping ballast to refloat them on the next tide. Nothing about it suggested speed or elegance. Navy men spent their entire careers learning never to run ships aground. This design violated every principle of seamanship that Annapolis had taught for generations. Yet within hours, copies were flying across the Atlantic to London. The British reaction was immediate and emphatic. Build them. The Admiralty had been struggling with amphibious warfare requirements since Dunkirk had demonstrated the catastrophic consequences of inadequate evacuation capabilities. Prime Minister Winston Churchill himself had demanded vessels capable of landing at least 3 36-ton heavy tanks directly onto beaches. Traditional landing craft could handle infantry and light equipment, but modern armoured warfare required heavy vehicles that existing designs couldn't accommodate. What those early planners failed to grasp was the revolutionary nature of what they had just approved. This wasn't simply another landing craft, an incremental improvement over existing designs. The landing ship tank would transform amphibious warfare by solving the fundamental contradiction that had plagued military planners since ancient times: how to move massive armies with their equipment across oceans and land them intact on hostile shores. Previous invasions required ports, protected harbors with cranes, docks, and infrastructure capable of handling the enormous tonnages that armies consumed. This design eliminated that requirement entirely. Armies could land anywhere there was a beach capable of supporting the vessel's shallow 4-foot draft. The implications were staggering, though few recognized them initially. Every coastal defense in history had been predicated on the assumption that invading armies needed ports to sustain themselves. Fortifications concentrated around harbors because harbors were choke points that defenders could fortify and attackers had to capture. The LST concept shattered that assumption by creating mobile ports that could establish themselves wherever tactical considerations dictated, rather than where geography provided natural harbors. But in November 1941, As the first detailed drawings took shape, few understood the implications. The vessel existed as an engineering curiosity, a solution to a specific British problem. Nobody calculated how many tons of supplies it might carry during extended operations. Nobody planned campaigns around its capabilities. The United States wasn't even at war, though tensions with Japan were escalating daily. German U-boats still prowled the Atlantic, sinking merchant vessels faster than shipyards could replace them. The Pacific remained peaceful, though intelligence reports suggested Japanese military preparations throughout the region. Hitler controlled Europe from Norway to North Africa, with German armies advancing toward Moscow and Leningrad. The idea that this ungainly vessel would help reverse all of that seemed not just optimistic but delusional. The global situation in late 1941 offered little reason for optimism about Allied prospects. German armies stood 30 miles from Moscow, having advanced over 500 miles in 5 months of continuous operations. Leningrad endured its first winter of siege, with civilian populations already dying from starvation and cold. Japanese forces were mobilizing throughout the Pacific, though their intentions remained unclear to Western intelligence services. Britain stood alone, having survived the Blitz but remaining incapable of returning to the continent with sufficient force to establish permanent beachheads. Every previous attempt at amphibious operations had demonstrated the same brutal reality. Landing armies on defended shores was nearly impossible without overwhelming superiority in every category. Gallipoli in 1915 had cost the Allies 250,000 casualties over 8 months of futile assaults. The lessons seemed clear. Modern defensive firepower made large-scale amphibious operations prohibitively expensive in human terms. Dieppe in 1942 would prove even more costly per man engaged, with Canadian forces suffering 68% casualties in a single day's fighting. The fundamental problem wasn't courage or tactical skill. Individual soldiers and units had repeatedly demonstrated willingness to assault heavily defended positions under impossible conditions. The problem was logistics, the unglamorous business of moving supplies from factories to fighting units under combat conditions. A single armoured division consumed 500 tons of fuel, ammunition, food, medical supplies, and spare parts daily during active operations. Multiply that by 20 or 30 divisions, and the logistics became staggering. An army group required 15,000 tons of supplies daily just to maintain defensive positions, with consumption rising dramatically during offensive operations. Traditional amphibious operations relied on capturing ports quickly to handle such tonnages. Major harbours could discharge thousands of tons daily using cranes, conveyor systems, and rail connections that moved cargo efficiently from ships to storage areas to fighting units. But ports were obvious targets, heavily defended and easily sabotaged. The Germans had learned from World War I, when American forces had used captured French ports to sustain the American Expeditionary Force. They weren't going to leave major harbours intact for Allied use. Demolition teams could destroy critical infrastructure in hours, requiring weeks or months of repair work before normal operations could resume. This created an impossible contradiction that had frustrated military planners since mechanized warfare began. Armies large enough to establish permanent beachheads against determined opposition required massive supply streams that only major ports could handle. But those ports would only become available after the beachheads were established and expanded inland far enough to protect harbour facilities from artillery bombardment. Smaller forces that could sustain themselves temporarily with preloaded supplies lacked the strength to hold against determined counterattacks, supported by interior lines of communication. Every previous invasion had foundered on this basic arithmetic. Niedermair's design offered a potential solution, though nobody yet understood its full implications. By creating a vessel that could cross oceans with full loads but beach in shallow water, the LST concept promised to bypass ports entirely during the critical initial phases of amphibious operations. Instead of waiting weeks or months to capture and repair harbour facilities, invasion forces could begin landing heavy equipment immediately. Tanks could roll directly from ship decks onto sand, ready for combat within hours of arrival. The tactical implications were profound, though they remained theoretical in November 1941. The engineering challenges were equally daunting, requiring solutions that violated conventional naval architecture principles. Ocean-going vessels required deep drafts for stability in rough seas, typically 15 to 20 feet for ships of that comparable size. Beachable craft needed shallow drafts to reach shore, ideally less than 5 feet to access most beaches during low tide conditions. These requirements seemed mutually exclusive. Conventional design wisdom held that vessels attempting to combine both capabilities would perform neither function adequately. Niedermair's solution was elegant in its simplicity, but revolutionary in its implications: variable ballast. The ship would ride low in the water during ocean crossings, taking on ballast water that provided stability and seaworthiness comparable to conventional cargo vessels. Before landing operations, powerful pumps would empty forward ballast tanks, raising the bow and reducing forward draft to less than 4 feet, while maintaining enough stern draft for propeller effectiveness. The vessel could then beach, lower its massive bow doors, and discharge cargo directly onto sand without intermediate handling. This ballast system represented genuine innovation, adapted from submarine technology and applied to surface vessels for the first time on such a scale. Submarines had used ballast systems for decades to control buoyancy, but applying the concept to large surface vessels required entirely new approaches to weight distribution, hull strength, and pumping capacity. The system had to work reliably under combat conditions with minimal maintenance, operated by crews who might have limited training in complex mechanical systems. The structural challenges were immense. The hull had to withstand the stresses of ocean crossings while loaded with hundreds of tons of tanks and vehicles. It had to survive deliberate grounding on unknown beaches with uneven surfaces and hidden obstacles. The bow doors had to open and close reliably under combat conditions, creating a watertight seal capable of withstanding heavy seas during ocean transits. Everything had to be simple enough for mass production by shipyards that had never built warships, and robust enough to function reliably when everything depended on it working perfectly the first time. Material requirements posed additional complications. Steel was already becoming scarce as American industry mobilized for potential wartime production. The LST design called for specialized steel plating and sophisticated welding techniques that would strain manufacturing capacity. Propulsion systems required marine engines that were typically reserved for higher priority naval construction. Every component had to be designed for reliability and maintainability, using materials and techniques that could be scaled to mass production levels. The human factors were equally challenging. LST operations would require crews capable of seamanship skills that no existing naval training programs addressed. Traditional seamanship emphasized avoiding groundings at all costs. LST crews would have to deliberately beach their vessels on hostile shores, often under fire, then execute complex ballast and cargo handling procedures while exposed to enemy action. The psychological demands of such operations were unprecedented in naval warfare. By December 7, 1941, when Japanese aircraft struck Pearl Harbor in a carefully coordinated surprise attack that crippled the Pacific Fleet, preliminary LST drawings were already being refined by teams of naval architects working around the clock. The attack transformed American industrial priorities overnight, shifting the entire economy from peacetime production to total war mobilization. What had been a design study for British requirements became an urgent national priority, affecting every aspect of American industrial capacity. Within weeks of Pearl Harbor, contracts were being negotiated with shipyards across the United States. The LST program was about to demonstrate American industrial capacity on a scale that even optimistic planners had considered impossible. But first, suitable construction sites had to be identified and prepared for production methods that had never been attempted. The challenge wasn't just building ships, it was creating an entire industrial infrastructure capable of mass-producing vessels that didn't fit conventional shipbuilding categories. The first challenge was finding suitable construction sites capable of handling vessels that were too large for many traditional shipbuilding facilities, but shallow enough to be built at inland locations normally unsuitable for ocean-going vessels. LSTs measured 328 feet in length with 50-foot beams, requiring building ways that many coastal shipyards couldn't accommodate. But their shallow draft meant they could be launched in water depths that would be inadequate for conventional warships. This geographic distribution of production would prove crucial as the program expanded beyond all original estimates. Shipyards appeared along rivers and lakes throughout the American Midwest, in locations that had never built seagoing vessels. Pittsburgh, Pennsylvania, became a major production center despite being hundreds of miles from the nearest ocean. Towns along the Great Lakes found themselves constructing ships destined for beaches they had never seen, operated by crews who had never experienced saltwater. The Cornfield Navy, as these inland shipyards became known, represented a fundamental transformation of American industrial geography. Traditional shipbuilding had been concentrated in coastal areas with access to deep water and established maritime industries. LST production democratized naval construction, spreading it throughout the industrial heartland where steel production, heavy machinery manufacturing, and skilled labor were abundant. This dispersion also provided strategic advantages, reducing vulnerability to enemy attack and utilizing production capacity that would otherwise have been unavailable for naval construction. Initial production contracts called for modest numbers that seemed ambitious at Mumsa and the time. The Navy's original requirement was for 200 vessels to be delivered to Britain under Lend-Lease arrangements that were still being negotiated with Congress. American military leaders remained focused on Pacific operations, where traditional naval vessels seemed more relevant to anticipated campaigns against Japanese forces. The Atlantic remained primarily a British responsibility, with American contributions limited to convoy escorts and material support. That figure of 200 LSTs would prove laughably inadequate as strategic planning evolved throughout 1942. As Allied leaders began serious planning for major amphibious operations, LST requirements exploded geometrically. Sicily would need dozens of vessels to land and sustain multiple divisions simultaneously. Italy would require hundreds to support extended campaigns in difficult terrain against determined opposition. The eventual invasion of Europe would demand numbers that seemed impossible to achieve within any reasonable time frame. Each operation revealed new requirements that planners hadn't anticipated. LSTs weren't just cargo carriers, they were floating supply bases, repair facilities, hospitals, and command centers. Their versatility made them indispensable for functions that hadn't been considered during initial design phases. This operational flexibility drove demand beyond simple cargo-carrying requirements, as commanders discovered that LSTs could solve problems that no other vessels could address. But in early 1942, as the first LST keels were laid at Newport News, Virginia, optimism remained cautious and qualified. The design was untested under combat conditions. Production methods were improvised using techniques that had never been applied to naval construction. Crews would be inexperienced in operations that violated every principle of traditional seamanship. Materials and components were being rationed for higher priority military production. Everything about the program represented a massive gamble on an unproven concept. The only certainty was that traditional methods of amphibious warfare had failed repeatedly throughout military history. Something fundamentally new was needed to break the deadlock that had characterized coastal operations since artillery had made ship-to-shore movements prohibitively dangerous. The LST represented the most radical departure from conventional thinking since steam propulsion had replaced sail, but its success remained theoretical until proven under combat conditions. What nobody yet understood was that they had just begun constructing the most important class of warship in naval history. Not because LSTs could destroy enemy vessels, LST, they carried minimal armament and were incapable of engaging warships in combat. Not because they were fast or heavily armored, they were neither, representing the antithesis of traditional naval design priorities, but because they could sustain armies across continents, delivering the enormous tonnages that modern mechanized warfare demanded without dependence on captured port facilities. The age of logistics-based warfare was beginning, though few recognized it at the time. Traditional concepts of naval power emphasized combat capabilities, SAS, the ability to sink enemy ships, bombard enemy positions, and control sea lanes through superior firepower. These concepts remained relevant, but they were being supplemented by new requirements that would ultimately prove more decisive. The ability to project and sustain military power across oceanic distances was becoming the ultimate measure of naval effectiveness. The first completed LST-1 was commissioned on December 14, 1942, exactly 1 year after Niedermair's initial sketch had been approved for development. It represented everything the design promised: a vessel capable of crossing oceans with full loads of tanks and vehicles, then beaching to discharge them directly onto hostile shores without intermediate handling. The commissioning ceremony was modest, reflecting the vessel's utilitarian purpose and the Navy's continued focus on more glamorous warship categories. But LST-1 also revealed problems that nobody had anticipated during the design phase. The flat bottom that enabled shallow water operations made for brutal seakeeping in any conditions beyond calm weather. The vessel rolled prodigiously in moderate seas, causing seasickness that conventional warships never experienced. The ballast systems worked as designed but required careful attention to weight distribution and pumping sequences that inexperienced crews found difficult to master. Crew quarters were Spartan even by wartime Navy standards. The emphasis on cargo capacity and mechanical reliability left little space for crew comfort or amenities. Ventilation was inadequate, especially in the tank deck, where vehicle engines created dangerous concentrations of carbon monoxide. Noise levels were extreme, making communication difficult and rest nearly impossible during operations. These conditions would test crew endurance and morale throughout the war. Yet they worked. The fundamental concept proved sound under operational conditions that gradually revealed the vessel's true capabilities. Through 1943, as LST production accelerated dramatically and the first vessels entered combat operations, these ungainly ships began proving their worth in ways that surprised even their designers. Sicily, Salerno, Anzio, the Pacific Island campaigns, everywhere Allied forces conducted amphibious operations. LSTs provided the heavy lift capability that made success possible. What had begun as an emergency response to British requirements was becoming the foundation of Allied grand strategy. Military planners were discovering that LST availability was becoming the critical constraint on operational planning, ASA, not aircraft carriers or battleships or destroyers, but these unglamorous cargo haulers that could deliver and sustain the enormous forces that modern warfare required. By early 1944, American shipyards were producing LSTs at a rate that defied comprehension and challenged every assumption about industrial capacity. What had begun as a modest program to supply Britain with 200 vessels had exploded into the largest single class of warship production in naval history. Every month, dozens of these flat-bottomed giants slid down ways from shipyards scattered across the American heartland. Pittsburgh steel workers who had never seen an ocean found themselves building ships destined for Normandy beaches. Detroit automobile workers applied assembly line techniques to naval construction, reducing build times from 4 months to 2. The Cornfield Navy, as it became known, was transforming American industrial capacity and Allied strategic possibilities simultaneously. The statistics themselves revealed the scale of the transformation in ways that peacetime observers would have considered impossible. By June 1944, over 800 LSTs had been completed, with hundreds more under construction at 32 different shipyards. Each vessel could carry 20 Sherman tanks or 60 trucks, plus supplies and personnel totaling over 2,000 tons of cargo. Simple arithmetic revealed staggering implications. The LST fleet could transport entire armoured divisions with their equipment directly onto hostile beaches, anywhere in the world. No army in history had possessed such capability for projecting power across oceanic distances. Production techniques evolved continuously, as shipyards learned to build vessels that didn't fit traditional naval construction categories. Modular assembly methods borrowed from automobile manufacturing allowed sections to be prefabricated inland, then transported to shipyards for final assembly. Welding techniques were standardized and simplified, enabling workers with minimal shipbuilding experience to produce acceptable results. Quality control procedures were developed specifically for mass production, emphasizing functional reliability over cosmetic perfection. The human dimension of this industrial transformation was equally remarkable. Shipyards that had employed hundreds of workers expanded to thousands virtually overnight. Women entered shipbuilding in unprecedented numbers, performing welding, assembly, and inspection tasks that had previously been restricted to men. African Americans found employment opportunities in skilled trades that had been largely closed to them before the war. The LST program was democratizing industrial employment while revolutionizing military capabilities. But numbers alone didn't capture the revolutionary nature of what was occurring throughout American industry. Traditional naval warfare emphasized speed, armor, and firepower as the primary measures of combat effectiveness. LSTs possessed none of these qualities in any meaningful sense. They were slow, lightly armed, and built for utility rather than combat effectiveness. Their maximum speed of 10 knots made them vulnerable to virtually any enemy vessel or aircraft. Their armor consisted of quarter-inch steel plating that could barely stop small arms fire. Their armament was limited to anti-aircraft guns and machine guns suitable for local defense only. Yet they were becoming the most strategically important vessels in the Allied fleet by measures that traditional naval doctrine had never considered. Generals who had initially dismissed them as glorified cargo carriers were discovering that modern armies couldn't function without the sustained supply streams that only LSTs could provide. The ability to deliver massive tonnages directly to hostile shores was proving more valuable than traditional measures of naval combat power. The education of military leadership in the realities of logistics-based warfare had been gradual but decisive, driven by combat experiences that challenged fundamental assumptions about how wars were fought and won. Early amphibious operations in the Mediterranean had demonstrated the critical importance of sustained supply in ways that peacetime exercises had never revealed. Forces that landed successfully but couldn't be resupplied were quickly defeated by counterattacks that exploited their isolation from supply sources. Traditional landing craft could deliver initial assault waves with their personal equipment, but lacked the capacity to maintain armies across extended campaigns requiring continuous resupply. Only LSTs could bridge the gap between initial invasion and permanent lodgment with the heavy equipment and sustained supply streams that modern mechanized warfare demanded. Each successful beaching operation delivered not just vehicles and supplies, but the capability to maintain combat operations indefinitely, without dependence on captured port facilities that might be unavailable, damaged, or within range of enemy artillery. This lesson was being learned simultaneously in the Pacific, where island-hopping campaigns depended entirely on the ability to project force across vast oceanic distances that dwarfed European theatre requirements. Each captured airfield or harbour had to be supplied continuously until it could support follow-on operations against increasingly distant targets. The flat-bottomed LSTs, with their ability to beach on coral sand and discharge heavy equipment, including construction machinery, made possible campaigns that would have been impossible with conventional vessels alone. Pacific operations revealed additional LST capabilities that designers had never anticipated. The vessels served as floating repair shops, using their spacious tank decks to service damaged aircraft and vehicles that couldn't be evacuated to major bases. They functioned as temporary hospitals, with medical personnel treating casualties in spaces originally designed for cargo storage. They became communication centers, command posts, and supply depots that could be repositioned as operational requirements changed. The men who crewed these vessels understood their importance, even if popular culture and military historians largely ignored their contributions. LST crews were typically young, often teenagers who had never seen the ocean before joining the Navy through draft calls that prioritized quantity over previous maritime experience. They learned seamanship aboard vessels that violated every principle of traditional naval architecture, developing skills that no existing training programs had addressed. Basic seamanship training at Great Lakes Naval Training Station or other facilities provided little preparation for LST operations. Traditional naval training emphasized avoiding groundings at all costs, maintaining proper distance from shore, and operating vessels that behaved predictably in various sea conditions. LST crews had to master the counterintuitive art of deliberately beaching 4,000-ton vessels on hostile shores, often under fire, while executing complex ballast and cargo handling procedures that required precise timing and coordination. The ships rolled heavily in moderate seas, wallowed unpredictably in following seas, and responded sluggishly to helm commands that would produce immediate responses from conventional vessels. In rough weather, LSTs became nearly unmanageable, requiring constant attention from helmsmen and engine room personnel to maintain course and prevent dangerous situations. Crew members who had trained on destroyers or cruisers found LST handling characteristics unlike anything in their previous experience. Yet they kept running under conditions that would have disabled more sophisticated vessels designed for combat rather than utility. The emphasis on reliability over performance paid dividends during extended operations when maintenance facilities were unavailable and spare parts were limited to what each vessel carried. LST crews became expert improvisers, keeping engines running with spare parts cannibalized from other systems, and maintaining ballast pumps using techniques that violated manufacturer recommendations but worked under field conditions. Maintenance was constant and creative, requiring skills that combined traditional seamanship with mechanical improvisation. The vessels were designed for reliability rather than sophistication, using commercial components wherever possible to simplify logistics and reduce training requirements. This approach simplified maintenance procedures, but required crews to master systems that bore little resemblance to standard naval equipment. Engines were adapted from commercial truck and bus applications rather than purpose-built marine designs. Electrical systems used automotive components that required different maintenance techniques than naval standards. The result was a unique naval culture that emphasized practical problem-solving over formal procedures, mechanical competence over military ceremony. LST crews developed pride in their ability to keep unglamorous vessels operational under impossible conditions, moving vital supplies while more glamorous ships received media attention and decorations. They understood that their contribution was measured in tonnage delivered rather than enemies destroyed, but their impact on the war's outcome was becoming increasingly obvious to anyone who understood modern military requirements. As D-Day planning intensified throughout early 1944, LST availability became the critical constraint on Allied strategy in ways that surprised senior commanders accustomed to thinking in terms of combat vessels and tactical considerations. Not aircraft carriers or battleships or destroyers, but these unglamorous cargo haulers were determining the scope and timing of the most important military operation in modern history. The reason was simple but profound. Operation Overlord required landing and sustaining more men and equipment than any previous operation in military history, creating logistical demands that only LSTs could meet. The planning figures were staggering by any historical standard and represented a quantum leap in the scale of military operations. The initial assault would put 150,000 troops ashore on the first day, supported by thousands of vehicles and artillery pieces that required immediate resupply to remain combat effective. Within weeks, that number would grow to over 1 million troops operating across a front that stretched from Normandy to Brittany. Supporting such numbers required tonnages that exceeded the capacity of major peacetime ports, delivered under combat conditions to beaches that had never handled commercial shipping. First Army alone required 23,000 tons of supplies daily by D+18, ammunition, fuel, food, spare parts, medical supplies, engineering equipment, and thousands of other items that modern armies consumed in quantities that would have seemed impossible to previous generations of military planners. Multiply these requirements by multiple armies operating simultaneously across separate sectors, and the logistics challenge became unprecedented in scope and complexity. Traditional supply methods couldn't handle such tonnages under the best of conditions, much less while operating from exposed beaches under enemy fire. Only direct ship-to-shore delivery could sustain the invasion force during the critical initial phase when port facilities remained unavailable or within range of enemy artillery. This created a strategic paradox that few outside the planning staffs understood. The invasion's success depended less on tactical brilliance or individual courage than on the mundane ability to deliver supplies continuously under fire. Beaches had to function as temporary ports, handling tonnages normally associated with major harbours like New York or Liverpool, using equipment and procedures that had never been tested at such scale. This requirement drove LST allocation decisions that affected global strategy in ways that remained invisible to most observers. Normandy operations would require 236 LSTs, representing nearly 2/3 of all available vessels worldwide. This concentration meant stripping LSTs from other theatres, including the Pacific, where they were equally vital for ongoing operations against Japanese forces that showed no signs of weakening resistance. The decision to commit such numbers to Normandy demonstrated Allied leadership's understanding that the invasion's success depended ultimately on logistics rather than tactics. No amount of tactical skill or individual heroism could overcome inadequate supply streams during extended operations against determined opposition. The LST fleet represented the margin between success and catastrophic failure in the most important military operation of the war. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The technical challenges were equally daunting and required solutions that pushed LST capabilities beyond original design parameters. Normandy's beaches offered unique difficulties that designers had never anticipated during the original development process. The tidal range exceeded 20 feet, among the highest in the world, creating conditions that changed dramatically every 6 hours. LSTs approaching at high tide found themselves stranded far from shore when the water receded, vulnerable to artillery fire and unable to discharge cargo until the next high tide cycle. Those beaching at low tide faced a quarter-mile transit across exposed sand under enemy fire, with heavily loaded vehicles struggling through soft sand that hadn't been tested during training exercises. Navigation was complicated by obstacles, both natural and man-made, that created hazards unknown during peacetime development. The Germans had spent years fortifying the Atlantic Wall with beach obstacles, designed specifically to destroy landing craft, including steel and concrete barriers positioned to cause maximum damage during high tide approaches. Underwater obstacles posed additional threats that required modified operational procedures developed specifically for Normandy conditions. Steel tetrahedrons, concrete blocks, and sharpened stakes were positioned to puncture hulls or damage propellers during beaching operations. Mines attached to obstacles created explosive hazards that could destroy LSTs during the vulnerable approach phase. These obstacles required careful reconnaissance and specialized clearance operations that delayed landing schedules and increased exposure to enemy fire. Weather conditions added another layer of complexity that tested LST seaworthiness beyond design limits. Channel weather in June 1944 was unusually severe, with high winds and rough seas that made formation flying difficult and beaching operations dangerous. LSTs, approaching through 6-foot swells, experienced violent motion that damaged cargo and stressed hull structures beyond normal operating parameters. Crews struggled to maintain control during final approach phases, when precise navigation was critical for avoiding obstacles and achieving proper beaching angles. Yet, as final preparations accelerated through May 1944, confidence in the LST concept remained high despite awareness of the challenges ahead. The vessels had proven themselves in the Mediterranean, where they had sustained extended campaigns against determined opposition under conditions that resembled anticipated Normandy requirements. Sicily, Italy, and Anzio had all demonstrated that LSTs could deliver decisive tonnages under combat conditions, maintaining supply streams that enabled sustained operations far from established bases. The Mediterranean experience had also revealed LST capabilities that hadn't been anticipated during original design phases. Versatility proved as valuable as cargo capacity, with LSTs serving simultaneously as hospitals, repair shops, communication centers, and temporary bases for specialized operations. This operational flexibility made them indispensable for functions that no other vessels could perform, driving demand beyond simple cargo-carrying requirements. The scale of LST involvement in Overlord reflected this hard-won confidence in proven capabilities. 236 LSTs assigned to the operation represented not just cargo capacity, but mobile infrastructure that could establish itself wherever tactical considerations dictated. Each vessel carried not just tanks and trucks, but the capability to maintain combat operations indefinitely, without dependence on captured facilities that might be damaged or unavailable. The human cost of LST operations remained largely invisible to contemporary observers focused on more dramatic aspects of amphibious warfare. These weren't glamorous assignments that generated headlines or medal citations in newspapers that emphasized combat action over logistical support. LST crews endured weeks at sea in uncomfortable conditions that tested endurance and morale, followed by dangerous beaching operations under enemy fire that required skills no previous naval training had addressed. They unloaded cargo while German artillery searched for their positions, often working around the clock to clear tank decks before the next tide cycle. They evacuated wounded while dodging air attacks that targeted the distinctive LST silhouettes visible from aircraft. They performed maintenance and repairs using improvised techniques and cannibalized parts, while operating in forward areas where normal support facilities were unavailable. Yet their contributions rarely received recognition proportional to their importance in sustaining combat operations. This anonymity was particularly pronounced among African American sailors who crewed many LSTs in segregated naval service that denied them equal opportunities for advancement or recognition. Despite facing institutional discrimination that limited their roles and responsibilities, these men performed their duties with exceptional professionalism under conditions that tested both technical competence and personal courage. Their service during critical operations like the Red Ball Express, MAI, the truck convoy system that later sustained Patton's advance across France, MAI, became legendary among those who understood supply operations. Yet they would return to a nation that continued practicing institutional racism, denying them the benefits and recognition that white veterans received. The contrast between their wartime service and peacetime treatment represented one of the war's tragic ironies. Men who had helped win democracy abroad were denied full participation in that democracy at home. The technical evolution of LST design continued throughout the production program as combat experience revealed areas for improvement and new operational requirements. Early vessels featured closed cabs and conventional marine equipment adapted from commercial applications. By 1943, production had shifted to open cabs with canvas covers that saved steel and improved combat utility by providing better visibility and faster crew movement during beaching operations. Weapons fits were standardized based on Mediterranean experience, typically including 20 and 40 mm anti-aircraft guns, plus 50 caliber machine gun mounts, positioned for maximum coverage against air and surface threats. Some vessels carried winches for beaching operations or handling landing craft that couldn't reach shore independently. Radio equipment was upgraded to support communication requirements that hadn't been anticipated during original design phases. But the most significant modifications were invisible improvements to ballast systems, ventilation, and cargo handling that increased operational efficiency without changing external appearance. These changes reflected lessons learned from combat operations and feedback from crews who lived with the vessel's limitations daily. The result was progressive refinement that made later production LSTs significantly more capable than early examples, though the basic design remained unchanged. Ballast system improvements reduced beaching time and increased safety margins during the vulnerable approach phase. Better pumping capacity allowed faster ballast adjustments that reduced exposure to enemy fire. Improved weight distribution systems prevented dangerous trim conditions that could make vessels unstable during cargo discharge operations. These technical refinements were invisible to casual observers, but proved crucial during high-tempo operations when every minute counted. Ventilation improvements addressed carbon monoxide problems that had caused casualties during early operations when vehicle engines were operated in enclosed tank decks. Better air circulation systems reduced crew fatigue and improved working conditions in spaces that reached dangerous temperatures during extended operations in tropical climates. These modifications saved lives and improved operational efficiency in ways that never appeared in official reports but were crucial for sustained operations. The strategic implications of LST capability extended far beyond individual operations, fundamentally altering the nature of warfare in ways that military theorists are still analyzing decades later. The ability to land and sustain large armies anywhere there was a beach eliminated geographical constraints that had shaped military planning throughout history. Coastal defenses that had been adequate against traditional amphibious operations proved insufficient against forces that could be supplied continuously, without capturing ports. This capability forced defending armies to guard enormous frontages with insufficient resources, creating strategic dilemmas that favored attacking forces with superior mobility and logistics. The German Atlantic Wall, impressive as it appeared to casual observers, couldn't defend every mile of European coastline against forces that could establish themselves wherever defenses were weakest, rather than where geography provided natural landing sites. Traditional defensive calculations became obsolete when attacking forces could choose their landing sites based on tactical considerations rather than port requirements. Defenders had to spread their forces along entire coastlines, creating opportunities for concentrated attacks that could achieve local superiority despite overall numerical disadvantages. This strategic flexibility transformed Allied operational planning throughout the war's final phases. As June 6, 1944 approached, the assembled LST fleet represented the largest concentration of amphibious capability in history and the culmination of an industrial effort that had transformed American productive capacity. Hundreds of vessels loaded with tanks, trucks, artillery, and supplies waited in British ports for the order to sail, their crews understanding the importance of their mission, though few grasped its full historical significance. They were about to participate in an operation that would demonstrate decisively how logistics-based warfare had replaced traditional concepts of naval combat as the ultimate measure of military effectiveness. The ability to deliver and sustain massive forces across oceanic distances was becoming more important than the ability to destroy enemy vessels in traditional naval engagements. Dawn, June 6, 1944. Omaha Beach, Normandy, France. The first LSTs approached through heavy seas, their flat bottoms pounding against 6-foot swells that would have been merely uncomfortable for conventional warships. Aboard LST 325, coxswain Robert Hartley gripped the wheel as his vessel wallowed toward shore. 20 Sherman tanks secured in the tank deck below, their crews already seasick from the brutal crossing. Behind him, dozens of identical vessels formed a mechanical armada, carrying the tools of liberation directly to Hitler's fortress Europe. What happened in the next 90 days would validate every calculation, every assumption, every desperate gamble that had transformed Niedermair's envelope sketch into the largest amphibious operation in history. The numbers would speak for themselves with devastating clarity. Over 2 million tons of cargo delivered directly onto hostile beaches. 700,000 vehicles landed. Over 2 million troops sustained across a front that stretched from Normandy to the German border. The LST fleet would move more tonnage in 3 months than most nations transported in entire years. German artillery opened fire as the first LSTs approached the shallows. Shells bracketed LST 329 as she grounded on Omaha Beach at 0630 hours. Her bow doors swung open, ramp dropped onto French sand, and the first American tanks rolled directly from ship to shore under fire. What the pre-war Navy had considered impossible was happening exactly as Niedermair had designed. Within 48 hours, the scope of LST capability became undeniable. 130,000 troops had come ashore, supported by 17,000 vehicles landed directly from LST tank decks. By D+4, Allied forces required 6,000 tons of supplies daily. By D+10, 9,000 tons. By D+16, over 12,000 tons per day. These numbers exceeded the capacity of major peacetime ports, yet they were being handled by vessels beached on open sand. Weather threatened everything when a severe storm struck the channel between June 19th and 22nd. The artificial Mulberry harbours were said or destroyed or severely damaged. Conventional shipping suspended operations entirely. Only the LSTs, with their ability to beach regardless of harbour facilities, continued delivering supplies. This storm validated the fundamental LST concept more dramatically than any planning exercise could have achieved. The psychological impact on German defenders was as significant as the material effect. Wehrmacht General Günther Blumentritt later acknowledged, "The Americans established a flow of supplies that we could never disrupt completely. Their ships could land anywhere there was a beach. We couldn't defend everywhere." The LST fleet had given the Allies strategic mobility that German forces couldn't match or counter. By August 1944, as the Normandy campaign concluded with German forces trapped in the Falaise pocket, LST operations had delivered the decisive material advantage that made Allied victory inevitable. Over 5 million tons of supplies had crossed the beaches, ammunition that kept Allied artillery firing continuously, fuel that enabled armoured spearheads to outrun German retreats, spare parts that kept equipment operational under intense use. The Pacific Theatre validated these lessons simultaneously. LST operations enabled island-hopping campaigns that accelerated the Pacific War's conclusion by years. Each captured airfield became a staging base for further operations, supplied continuously by LSTs that could beach on coral sand. The post-war assessment was unequivocal. General Eisenhower identified the LST as one of 6 weapons that won the war, alongside the atomic bomb, radar, the C-47 transport, the jeep, and sonar. For the Supreme Allied Commander to rank a cargo vessel with nuclear weapons indicated fundamental reassessment of military priorities. Logistics had emerged as the decisive element in modern warfare. The production statistics told their own story. Over 1,000 LSTs completed during the war, with construction time declining from 4 months to 2 months. Peak production reached 30 vessels monthly. This industrial capacity represented America's ultimate strategic weapon. The human stories remained largely untold. Thousands of young men won the war 1 ton, 1 mile, 1 delivery at a time. They operated vessels that violated every principle of seamanship, in conditions that tested equipment and endurance to their limits. Their contribution was measured in tonnage delivered rather than enemies destroyed. The LST story challenges romantic notions of warfare. We celebrate decisive battles and brilliant commanders, but none would have mattered without continuous supply operations. The LST won through the most fundamental capability, delivering supplies where needed, when needed, in quantities sufficient to sustain operations until victory was achieved. John Niedermair's envelope sketch had become the weapon that moved 2 million tons in 90 days and demonstrated that logistics, not tactics, would determine future wars. The vessel nobody wanted to discuss alongside tanks and aircraft had proven more indispensable than either. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.